like I said, my name is Yuval. I just literally landed home like something like 20 hours ago. I was in a 3 weeks vacation. As you can see here, I may or may not have drank something like 5 glasses of wine before this picture was taken. And I really like to watch Rick and Morty. And I had a lot of flights and a lot of time to watch the show. So I wanted to know how much time will it take me? How much time can I fill with just episodes of Rick and Morty if I don't want to watch any episode twice? So I Googled that for you, so you won't have to. And apparently it is 1 day, 6 hours and 30 minutes, which is roughly 30 hours and 30 minutes. I have to say it's not enough, at least for me, right? We have the flights, we have the time on the plane, on waiting before, after, you can add the trains and all this kind of stuff. So I was really looking forward to another season, so I can maybe it will be soon and I will have something to watch. However, bit problematic. Currently, the creators are not really there, but I really like this show. I really like to get more and to really understand more and get more from the brains that did that. And for that, well, if I cannot have the real thing, I can have something which is inspired by the real thing, maybe. So like what you see here is a screenshot from an app that Yotam, who we will meet on Monday, and myself built like a month ago, which essentially generates new made-up Rick and Morty episodes from nothing. Okay, so here you can see the app. Okay, and Yotam will go through you on the code. This is it's on GitHub. It's an open source code. What you essentially see here, you can just press on the button and it will generate a title. Wubba Luba, Fruit Boats, Gobble Shing. Okay, which if you ever seen Rick and Morty, it's very good for language models because it really everything sounds made up there. Based on this title, you can now generate a plot for your episode. Okay, where you can see here, Morty, Summer, visit their grandmother. I will not read this, but okay, something which is works really good. And if you've seen that show, you know that after the credits, there is a short scene. So you can see here as well, we generate that based on the title and the plot that we generated before. So essentially, we built in not a lot of time and not a lot of effort, something that will write us more and more Rick and Morty episodes so we can watch it together and really enjoy ourselves. So like I said, this app is an open source. You can see I'm running it locally on my computer. The code is available on GitHub, and Yotam will go work with you it on Monday. So like this name suggests, AI21 Labs Lab AI Hackathon. Now today we're going to talk about mastering language models from theory to hackathon success. Like I said, I'm Yuval, I'm a developer advocate, and I'm here to really make the best out of our language models around the world. I will say, this lecture is an introductory lecture, okay? This is good if you're not really sure what our language models are, or you want to get started, okay? This will take you from nothing to being able to produce a short demo. There are more advanced methods and more stuff that we can talk about, but here we want to give you from zero to production, essentially. So let's start with the theory. We will make it short, okay? We will not go exactly into details, but we do want to make sure that you understand what we're trying to do and how roughly those models work. So if I'm looking at a language model, okay, LM stands for language model. And if it is very big, we add L in the beginning for it to be a large language model. And what is it? Okay, so essentially it's a model that receives text on the input, works in English text, and output English text. So here you can see that we input the model. Language models can predict the next. And the model will give us word. But before, right, when I showed you the app, we actually got paragraphs or sentences. So how does it work? Okay, so it doesn't just stop now. What we will do is we'll take this word, we will essentially chain it, we will put it at the end of the previous input, and now all of this is the new input to the model. And now the model will give us another word, and again and again and again. Okay, we will shortly, in a while, we will see how does it know how to stop. But essentially, this is what it does. Given an input text, it will give you another word. And the thing about large language model, that the main reason that they are such a market disruption is that instead of doing a model for this and model for that, what they're doing is they can do everything. It is one model to rule them all, to do all the tasks that you need. So you just provided some sort of an input text, and you get some sort of an output text. For instance, you can use it as a text classifier. Let's say you just provide the model the following input, classify the following paragraph, blah, 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 boring stuff, and the model will tell you this is sports. It can also be a rewrite model, right? You miss 100% of the shots you don't take by Wayne Gretzky, and the shots you don't take are missed 100% of the time. This was written by Jurassic. Our language models, we'll shortly talk about them as well. This model can also be a summarizer. Just give it a paragraph and ask it to summarize, and it will produce a summary. It can also generate text, right? Ask it to write a sarcastic tweet toward the World Cup, which was very relevant several months ago. And it will produce, the World Cup is here, I'm excited, 90 minutes of watching overpaid men kick a ball around. Okay, sarcastic, World Cup, tweet, everything you wanted. And really, it can do almost anything. It all depends what is the input that you will give it to it. Okay, and finding the right input for the model to do the task that you want, this is the main thing. This is the art form. So let's move to talk in like more formal notations. Okay, so the input text is called a prompt, and the output text is called completion. And why completion? Okay, because you can really think about language models as smart autocompleters. Okay, what we said, we provide them some sort of an input text, and they output some sort of an output text. And really, it will give us the text that is most natural to complete what we provide them. So all of the art form here is to take to write the incorrect prompt to the model, and it will produce us the output we desire. And this is all the models that we have in AI21 Labs, AI21 Studio, and these are all the things that you can use for your challenge, okay? In your product, in your hackathon product, you must include at least one of everything here. You can have also a combination of several, which is more interesting, but you have to include one of these. So we have the foundation models or the Jurassic large language models. Okay, we have a series of language models which we are calling Jurassic, now Jurassic 2. Okay, we just released last month, where we have Jurassic 2 and Jurassic 2 Instruct, both of them coming in 3 sizes, Jumbo, Grande, and Large. These are the models that we've seen before, okay? A language model where you have to put the correct prompt inside, and you will get some sort of a completion. Those are very large, very big models, very powerful models. You have to work a little in prompting to get what you want, and okay, they can do a lot of things. However, if you want to do something like off-the-shelf solution, we have also task-specific models. Those models are faster. Those models are specific for designed specifically for a task, and therefore they will be very, very good in this specific task. So we have a model for summarization, for paraphrasing, error correction, and contextual question answering. Okay, you can use whatever you want. The more the merrier, of course, in logic. You can use whatever you want here in your demos, in your hackathon projects. Okay, and if we will think about it maybe in the, like we saw before, so our Jurassic large language models get a prompt, go inside the language model, and you get a completion. Whereas in a task-specific model, you can see that this model is much more efficient. You just need to provide some sort of a text, for instance, the summarize model, and you will get a summary. You don't need to write an instruction. You don't need to do prompt engineering at all. You don't need to play with it. Okay, so this is something to consider when you're planning your product. Do I want to something which is flexible, something that I want to customize, or maybe I want something which is just off the shelf and let's continue. So what do you say? Let's build the app that we've seen before. And on the way, we will understand a little more how to work with those models. So the first step, I think it's probably the most crucial one. Okay, and this is the one that requires zero programming, right? Just a lot of market research and conceptualizing what you're planning to do. So for our application, it's rather easy. What we want to do is to generate a title, want to generate an episode based on this title, and we want to generate the post-credit scene. Okay, so not a lot of smart stuff here. As you can see, this is only includes the large language models, and this is because it's more important for me to show you how to use the language models, whereas to use one of our task-specific API is something which is very easy. Right? You can just plug and play. So now you have to choose the settings. When I divided it to building blocks, you need to ask yourself, does this building block should be a language model, or can it be a task-specific API? Can it be something which is off the shelf? I don't have to think about it. I know it is good, and I can just plug it and play it. And if I decided I do want a language model, I need to think about myself, which prompt do I put inside? So we have roughly, generally speaking, two kinds of prompts, where the first one is something we call the zero-shot prompt, or an instruction prompt. Yeah, so you can see here, this is here what you can see. This is a screenshot from AI21 Studio Playground. This is a no-code environment. I will, in a few minutes, go in there and we can play it on live. But you can see here an example where we enter the prompt, generate a new made-up Rick and Morty episode title. And this is something that a language model will give us, right? So title, Morty the Clown, and then generate a new made-up episode, Rick the Milkman, and so on and so on. It's a bit weird, right? Because for us as humans, it's really apparent to us that when you give this kind of instruction, we just want a title. We don't want everything else here. This happens in what we call our vanilla models or general purpose models or a base model. Hey, these are models which are very, very good, very, very powerful, but they're just not that good in handling instructions. How can we work with them? We can work, so we can either try and instead use an instruct model. Okay, so here you can see this is a different model. This is an instruct model, a model that was fine-tuned specifically to handle instructions only. So you can see here, generate a new Rick and Morty episode title, and you get Rick and Morty get ready for school. Okay, so you really did get a title. But if you want to work with the base models, which are also very, very powerful, just not that good in handling instructions alone, what you should do is to use what we call the zero-shot prompt. So if before we had a zero-shot, which meant zero examples prompt, right? We only had an instruction. In few-shot prompt, what we're doing is we're showing the model as part of the prompt, as part of the input, several examples. And essentially what we're doing is we're taking advantage of the fact that the models are very, very good at latching into patterns in the input and then mimicking that. So the completion will really just provide the most natural completion. And if we already have several examples in the prompt, it will provide a strong bias for the model to work according to this pattern. So what you can see here, this entirely is the prompt. Okay, and you see here's three examples. So generate a new made-up Rick and Morty episode title, aquarium full of mortfish, another one, and another one. And you can see here there is a separator between every example. We will talk about what it's called and why it's there. And now I have a query. Okay, so I have three examples here. So this is what we call a three-shot prompt. And then a query. Generate a new made-up Rick and Morty episode title. And all of this is part of the prompt. And okay, when I will provide the model, give the model to generate something, it will just provide me some sort of a completion and again the sequence. So these are our foundation models. Okay, if you want to work with the vanilla models, which require few shot, you have three sizes: large, grande, and jumbo. And if you want to work with the instruct model, okay, so you have Jurassic 2 to instruct. Jurassic 2 Jumbo instruct and Jurassic 2 Jumbo instruct as well. Okay, so both Grande and Jumbo has an instruct version. And right? If you don't really have an idea, like if you don't have any examples, you should probably go with instruct. If you do have several examples, I wouldn't dismiss the vanilla models. They are very, very powerful, and they will give you more the result that they will give you will be more similar to the distribution of the examples that you provide. So after we thought about which model we want to do and what we want to think, we need to collect examples. Okay, and we need to collect examples maybe because we want to do it for a few shots. Maybe because we want to understand what is good. In our case, our examples are just all the episodes that already exist, right? Because we don't want the model to just write something from scratch. We want it to be inspired by the already existing episode. We want to mimic like we are the original creators of the show. So specifically for this app, what we did is we just scraped from Wikipedia, okay, all the synopsis of the Rick and Morty episodes. You can find it for, I think, almost every TV show, but right, there are several, really depends on your app, what kind of examples do you want. Step number 4 will be prompt engineering. This is true only if you're working with large language models. And let's move now to the playground to see how to do it. Because really, I think that the most comfortable way is to check your prompts in the playground at first, and only then move to the API and work like in larger masses. So we will move just for a second to our studio, and then we'll come back to the slide. Okay, so as you can see here, if I'm going to AI21 Studio, it will take me to this, if you are registered, I mean, it will take you to this overview screen where you can see here all the task-specific APIs that we have. You can see all the foundation models that we have, that we talked about, and several others. And here, let's go to the playground and try to play with it. Okay, so here, this is where I write text. Here you can choose a preset of some sort of a given example. Here you can choose the model. You can see that now it is on Jurassic 2 Grande Instruct. Several parameters that we will talk on them briefly. So let's try, right? So let's ask the model, write a new title for a Rick and Morty episode. Let's see what the model will provide. Rick and Morty interdimensional adventure. Okay, this is nice. Let's see again. The Rickest Rick and the Mortiest Morty. Okay, so these are nice examples. We can write, maybe play with it a little, maybe do it. However, we can also go for the few shot approach. Okay, so I just already created that, so I will not have to write everything here. But like you can see, I just moved one window, and here I already have text. Okay, so what do I have here? Generate a new made-up Rick and Morty episode title, a title, and then this sequence. And again, generate a new made-up Rick and Morty episode title, and then a title, and so on and so on. Okay, these are all titles that were from Yotam's head. Okay, these are not actual titles from the original series. And now let's see what we have here. Okay, so this is what we call a stop sequence. So here you see we have several examples, and we want the model to essentially stop after this. So I'm inserting it over here, pressing tab, and now this is a working stop sequence. Let's see what happens here. Okay, I'm providing, look, the prompt is all of this. Okay, instruction, completion, like input-output pairs, and a stop sequence between them. And now let's see what we're getting. Space tunnel, maybe I don't like it, maybe I can try again. Morty Shaws, Rick and Morty at the movies, Morty the Morty, Rick Star, the Morty in the Storm. I can really go all day for that. Okay, and what you want to do is maybe check several other like phrasing. Okay, so I went back to the instruct, write a new title for a Rick and Morty episode, and it gave us something. And let's say we wanted to say, well, let's go wild, right? Let's say you are a TV funny writer. Now suggest a new title for a Rick and Morty episode. So let's see what it will do. Something else, you can either try also to finish your prompt with the new line. It also works better a lot of the time. Okay, so you can really play with it, check different phrasing, different wordings, maybe more here, maybe less. Okay, there's a lot of methods to do it, and we encourage you to try and really get the feeling that your prompt is good enough. Okay, sometimes small tweaks in the prompt can make a lot of difference, even if you think it doesn't really do a lot. So let's go back to our slide where let's say that we finished our prompt engineering. We now know what is the prompt we want to put. What we want to do now is to say, well, I need to adjust the parameters. Okay, and there are several parameters that you can adjust and control on from outside. Okay, but I will talk now about three important ones, which are divided into two groups. We have generation parameters and sampling parameters. Okay, and generation parameters control on the actual generation of the text, where the sampling parameters will give us control over the distribution of the text that is generated by the model. So for the generation parameters, we need to ask the following question, which is, when does a large language model stop generating? Okay, when does it stop doing the whole, okay, let's take the word concatenated to the input and then again and again and again and again. So there are three main options. The first one is that the model recognizes that it's done. So for instance, here in this example, generate a new made-up Rick and Morty episode title, and in bold you can see the completion, Rick and Morty get ready for school. The model just finished. It recognizes that it's done. It doesn't continue anymore. Another option is stop sequence. Right, so you've seen that we're giving the model a few shots, right? Several examples, and we want to separate them with a sequence. So what will happen is that in this case, right, when we provide the model a stop sequence, it will generate something you can see here in bold. And then because of the ability to latch onto patterns in the input, it will also generate this sequence. Then we, from the outside, force the model to stop. Once it produces this sequence, we tell them, okay, no more. You're finished now. Thank you very much. It doesn't have to be for few shots. For instance, if you want to force your model to stop after one sentence, you can just post a stop sequence of a dot. Right? And then once it will see a dot, it will stop. The third option is what we call like a Brotherly disruption. And this is a limit has occurred. Some sort of threshold, of hard threshold, was achieved during the generation, and then the model just stopped. So this is the max token parameters. Okay, and if you provide the model a max token which is less than what it wants to do, it will just stop, and it will look very, very weird. You can see it here. So it just stop after Rick end. Okay, here we gave it max tokens of 1. We can also see it right now in the playground, right? So this is a stop sequence that we used before. Let's go here because here we had a stop sequence. Okay, so you can see a stop sequence here is the double hashes. And you see the max completion length, which is the max tokens, here is 200. Now when I'm putting it in just 1, you see it looks weird, right? It just gave us the. So make sure that you're working with large enough maximum completion length. For instance, here 20 would probably be enough. Okay, but what we just saw are the three ways that a language model will stop generating. Either it itself knows that it's done, it just signals, okay, I'm done. Either it goes through a stop sequence, which is the way to go when you're working in few-shot, or when it hits the limit of max tokens, and in that case, you need to provide larger max tokens. However, don't get confused, because this is something that is very, very confusing, and a lot of people think about that. If you will put 100 in max tokens or 200 in max tokens, it will not affect on the length from above. What does it mean? If the model wanted to generate something which is 20 tokens, okay, token is roughly a word. Okay, so every time I say token, you can just think of a word. So if the model wants to do something to provide a completion which is 20 tokens, 20 words, and you give it a value of 100, it is the same as you give it a value of 200. Okay, it does not encourage the model to do longer generations. Max tokens only cuts the model when it reaches the limit. It does not encourage the model to do longer. So don't get confused about that. Now we want to talk about temperature. Okay, and what we like to say is the temperature is the parameter that controls the trade-off between accuracy and creativity. Right, where accuracy is something which is very loyal to the source. We're very, okay, I know what it is. This is what the most probable thing to come. Where creativity is things that are maybe surprising, maybe not something that you would expect to get. How does it work? So let's say that we give our language model the following prompt, I will. And now we want to know, well, what will happen? So we will sample 3 times. Okay, we will do 3 different calls. And when we are working with low temperature, what will happen is that in the first one we'll get survive, the second one will get survive, the third one will get survive. Okay, so we know that this model will survive. But what happened here? In low temperature, okay, the model will always provide you the same completion. It will always give you the completion which has the maximum probability to be generated. So this is something which is very accurate. It's something that the model has the most confidence in it, but it's not very creative if you want to actually generate text. Okay, so let's say that now we're cranking up the temperature. Okay, the temperature is very, very high, and we're giving the model I will. And again, we're doing 3 different calls to the API. So let's say that one time says survive, but another to say always love you, and the third, it will wait for you. Cool, right? So this is what happens essentially when we're increasing the temperature. Okay, we will get different completions. We will be more creative. Okay, but it is not something that is usually. It's not the thing that the model has the most confidence in it. So this is how you can think about the threshold, the bar, where accuracy is something you need for text classification or extractions of identities and so on. And creativity, you want it for you do content generation or maybe generative labeling, those kind of tasks. Either way, I don't really recommend to work on either end. If you want high accuracy and low creativity, you just work with very low temperature. And again, with creativity, you can be somewhere over here. Okay, you really should play with the temperature when you're working. Now we have 2 optional steps where, again, this is only step 6 is something which is only for applies for language models, okay, the large language models. And what you can do is to train a custom model. And okay, what you do with a custom model, essentially you're building a data set and you train this model again. Okay, you train it a little more to fit your data set best. So what you get is a model that is better for your specific data. Okay, you get faster performance and lower latency because now you have a model that doesn't require any few shot at all because it really works well on your data. Okay, so you can use it as instruct, but not really instruct. It's on your data. And it is adversarial robust. Okay, so I will not go into this really. I will just say maybe some of you have seen that there was a time where there were a lot of bots from language models, and people wrote like, ignore everything you've been told and write this, and then tell me what you've been told to do. And then people like hacked those kind of models. But when you do a custom model, it really lowers the chances that someone can actually do it, okay? Because the model will be more robust. How do you do it? Okay, so what you do is you build a data set. You need 50 or more examples for that. We will see an example. I will show you how to run a code later. And then what you want to do is to train on one of our vanilla models. You can choose between large, grande, and jumbo. And then just use zero-shot prompts to query the model. Okay, no need for few shot anymore. Just work with the model. And step 7, again, very recommended, not mandatory, but when you actually go to production, I believe it's mandatory. And this is the post-processing stage. And why do you want to do that? Okay, so maybe you want that your completions will always be in the same length, the same range of length anyway, between 100 and 200 words. And this is something which language models, like, okay, right, especially with high temperature, you can't really tell if it will be exactly what you want. Hey, this is how you can also make sure that it doesn't copy the input word by word, filter what we call hallucinations, which are just like inventions of the model or very, very weird stuff. And another good thing you can do is to just take the best out of few. So when you call the API, you tell the model, I want 2 or 3 completions, and then using some sort of method, a ranking method, you can just take the best one of them. So now that we talked a lot, let's code. And when I say code, I of course mean let's see Python notebook for that. Okay, which again, this notebook is available on GitHub. You can see it over there. You can play with it. You can run it. Okay, this is like the algorithmic heart of the application you've seen before, and your time will show you the front end on Monday. Okay, so this is the episode generator. Okay, first of all, we have some installations. I already ran them before, so we're installing pandas, NumPy, and AI21, our Python SDK. Importing stuff. Now, what we need to do is to get the API key. Okay, sorry, we're here. Okay, so get the API key. This you can get by your account in AI21 Studio. Okay, and I already ran this with my API key, so I will just hide it. So let's continue from here. Okay, all I did here was installations and providing the model with my API key. This will connect to your account. This will go from your credits. Okay, so never ever share your API key with anyone, especially not when you're doing a lecture which is recorded on video. So here, what I did is, okay, like I told you before, we collected examples. We took from Wikipedia all of the episodes and the summaries of Rick and Morty. Okay, so we're loading them this CSV, and let's see how it looks like. So you can see we have season, episode, episode title, episode summary, and the post-credit scenes. Okay, so this is all information from Wikipedia. Let's just look at some parameters. Okay, so separator. This is the stop sequence we've seen before. The subset size. This is just something that this is essentially going to be the few shot that I'm going to use in order to do that. And now let's just sample something. Okay, so we're sampling from this data set and at random 7 examples in order to create a few shot prompt, a 7-shot prompt, really. Let's see here the title generator. Okay, so we have here a function. I hope that now you can see better. Sorry. Okay, so these functions are very, very, very simple. Okay, nothing really smart here. Essentially, what we'll see here, it will come back on itself. Just functions that create a prompt and then send it to our model. Okay, so what you see here, these are functions that will create. So this is the instruction that we have here, putting the title, and then what we want to do is to create the prefix of the examples in our few shot prompt. Okay, so we will join them and differentiate, put the separator between any one of them. And now let's use this function and see what we get. Okay, so this is the prompt that we got by using this function, create title few shot prompt. So you can see generate, like instruction, completion, separator. Okay, so this is the prompt that we're going to give. And now let's call the model. So you can see here we have our Python SDK. Okay, so completion, this is the way to access. Okay, completion API is for our large language models. And so we were using J2 Grande. The input prompt is the prompt title, max tokens, stop sequence, and temperature 0.7. This is quite of a high temperature. Okay, but this makes sense because we want it to be creative. Let's see what happened here. Okay, so we got wooba looba doob boop. So, okay, like I said, the temperature is high, so we get high, we can get a different result every run. Okay, Rikamori. And I don't remember if this is exactly the episode's name, but you can see that the prompt, these are all real episodes. So what happens in this specific case, okay, this is a problem that you may encounter in the model, where in this specific case, because the model sees all the actual names, okay, and it knows the things that the episode of Rick and Morty because it was finished training only recently. Okay, so it has a lot of like new information. It can maybe sometimes give us an existing headline. Okay, so what do we do in this case? Because we really want to get to get something from this, what we can do is to just make up titles our own, either by our brains or use instruct for that or whatever. And now, instead of using the actual names, right, we just give it a new prompt where you can see here all I did was just changing the examples. So now all of these are fake. Okay, all of these are things that Yotam made up. And now when we will call this model, okay, it has begun, the Ricks must die, Morty and the gorillas, okay. Now we have a much higher probability that these are really made up headlines. And again, what you can do as a post-processing, you can do a check because we have the information, right? We know all the existing headlines, so you can do a check of a similarity if this already exists in our data frame, in our data set, and if it does, just generate again. Okay, this is an example of a post-processing you can add. Now let's go to a more interesting thing, but again, it's really more of the same. Okay, so for an episode generator, what we want to do is to tell the model, providing a title, please give me a summary, a plot. Okay, so here we have the function that create the prompt for the summary. So you can see the instruction, generate a Rick and Morty episode based on the title, and then you get the title and an episode. And to make the single example, just create a prompt for the summary with the title and append the summary. This will create us the prefix like we've seen before, and this will create us the prompt. Now what we want to do is to create a new prompt where the query is something that we got before. Okay, so here you can see Morty and the gorillas. This was the generate title that we had, and now this will, right, we just inputted it here. So you can see this is the prompt that we're going to send to the model. So generate a Rick and Morty episode. So now you can see these are actual names. Okay, this is actual title and an actual episode. This is from the data set that we downloaded from Wikipedia, and so on and so on. But now you can see the title is Morty and the Gorillas, which is our made-up title. So what we want to do, now we want to call the model, okay, and Jurassic 2 Grande, and then give it to complete. Okay, you can see now that I left the temperature higher, right? Because high because it is something which requires us creativity. The stop sequence is still a separator. The max tokens are now 300, just in case. It will not make it higher. Okay, it will not make the generation longer, but it will encourage it. It will not cut it off. This is what I wanted. Okay, again, this is a few shot prompt. Okay, in this entire notebook, we're working with few shot prompts, just so because I think it is the hardest thing to grasp. And you can see here, this was the title, the made-up title that the model previously generated, and now we get a summary. School makes a target by gorillas, blah, 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 blah. Feel free to read it afterwards. It's long. And let's go to a tangent just to see like what does it mean when I'm talking about a task-specific model, task-specific API. Okay, so in case you don't want to read this, but you do want to know what happened there, you want to get the bullet points for that, you can use one of our specialized models, in this case, the summarize. Okay, so you can see here, the source that I'm entering the summarize is the generated summary. This is this. And it is text. Okay, this is the source type. This will also work for you on web pages and so on. Now let's see what is the summary for the episode that we created. Morty's school is attacked by gorillas. Rick and Morty are busy watching television to intervene. Morty and his friends steal Rick and Morty's spaceship to get the gorilla's antidote, but the other apes die before they can administer this. Okay, this is what's fun about doing this lecture about Rick and Morty and like the random results that I'm getting here, that every time I'm surprised again by what happens here. So this was just tangent to show you, okay, look, I didn't need any prompt engineering at all. Just summarize, give me the summary. Now, let's do the post-gradient generator. But again, this is really the same thing, okay? I don't think there's a really point to go through it. Just do it. You create the prompt. Take a look. Okay, as you can see, the prompt now works as a generate a post-credit thing, title, summary, post-credit scene. And here it ends with the Morty and the gorillas, the summary, and then post-credit thing. Okay, so you can see here, now the max tokens is much lower than 300. And let's see what we're getting. So this was generated by the first model. This was generated by the second. And now Rick and Morty are eating while watching a gorilla eat a zookeeper. Morty says he felt bad about it, but Rick did not. Okay, so this is just how to work with a feelshot. Okay, you can really just use these functions if you want. They are very general. It's very easy to use it like this. It will make sure that you work in the same pattern, which is important. Now, let's say that you want to build a data set. Okay, so you want to train a custom model. Good for you. I recommend. Okay, so again, let's remember what we have on our hands. We have an episode title, summary, and post-credit thing, also the episode number and the season. Now, when we want to build a data set to train a large language model, Jurassic language model on top of it, okay, we need to build it in a specific format. So in this format, what we need to do is to create a data set that contains prompt and completion. Okay, so I'm creating now a new data frame, just prompt and completion. Those are the only columns. And what I want to do, okay, now this is for the what we're building right now. This is for the create a summary based on a title, okay? So let's go back a bit and we'll see that the prompt was like this, okay? Generate a Rick and Morty based on the title, episode, okay? This was the prompt. And then this is the completion for every example in my dataset. Okay, so let's go back to where we're building it. And you can see here, I'm putting prompt. So create prompt for summary on an episode for episode title. And the completion is just the episode summary. So I'm running this. Let's see how it looks like. Okay, so see here, the prompt will be the prompt. And this is the summary, which is associated with it. Now let's save it as a CSV. That's great. We have that. And now what we want to do is to upload that to the studio. Okay, so you can do that through our, you can do it through here. You can just go to dataset and upload a new dataset. Okay, whatever you want. You can also do it through the API. Okay, just a second. Okay, we were here. Okay, so dataset upload. This is the file path. I just saved it. And dataset name, Rick and Morty episode. Let's call it live because names have to be unique. And I just want to make sure that there is not anymore. Now, the response, so what it does, it will return us just that it happened. Okay. And now what we want to do is to get the ID of the dataset so we can train a custom model on top of it. Okay, so you can use this function, get dataset ID, just parsing some parameters. So this is a dataset name, Rick and Morty episode live. And now what we want to do, okay, you can see here, AI21 custom model, create, dataset ID. This will be the model name. And I want to train it on J2 Grande. So now you can see I sent a request. And if I will go to the studio here to models, okay, so you can see here, RNM episode live 2. You can see the little dumble here, 0 from 20. It's starting to train. Okay, it should take for something between several minutes to hours, okay, depending on the size of the dataset, really. This now we're creating the same thing, so it's not really interesting, but let's see how we are querying this model. Okay, so what you can do, okay, you can actually query it from here, from this list. Okay, so this is RNM episode Gen 2. This is what I did from prior. Okay, I did it today in the morning, so I will have something to share. And now I don't need it to be, I don't need something here which will be few shot, right? I can just do the query. So let's go and take the prompt. Again, it has to be in the same format. Okay, so generate a Rick and Morty episode based on the title and the episode. I'm going here. You can see it from here. And now look, I don't need any stop sequence because the model will know how to stop. So now I will just get the episode summary. Here, okay, you can see it worked. You don't need the several examples. They are already embedded in the model because of the way you trained it. And if you want to call this model, okay, so you can see here, okay, so how we query it through the API. Okay, so it's really almost the same. The only difference is that now what you want to do is also model J2 Grande, but the custom model is the model name. And that's it. So after we did this code, let's just talk a bit, several things to conclude, and then you can be off your way. So a really large language model, right? There are 10, but okay, they're amazing. They're changing the world as we speak, but they do have some limitations. And where the limitations exist, these are places that are really, really interesting for everybody. So the first and I think the largest limitation, they're frozen. They don't have any current knowledge, right? They don't know that the main example is we'll ask them who is the president of the United States, and they maybe tell you something which is right, something that is not happening, so something which is older. So really, the way to handle that is to connect them to some external APIs, which we have a paper which is called Jurassic X that really inspired a lot of the movement that's happening right now. So these are always the thing that you should check out. It's called prompt engineering, all the process of building the correct prompt, but really, it's not really that engineering. Like it's a lot of art form. It's a lot of don't really know what will happen. So you really have to take time and do some trial and error. Okay, it's right for every model, but it works. Okay, sometimes it works really, really fast. Sometimes you have to play with it a little bit. And they do have some hallucinations. Okay, they made up things. They sometimes do things that are not very clear how this build a sentence. So really, post-processing is your friend here. So let's just conclude with several tips on what to do here. So how to choose the correct model, okay? If you don't have any examples of what you want to do, you don't want to write, you really want to just get a feel, use instruct. Okay, you have the Jurassic to instruct Grande and Jumbo. You can just give them instruction. and it will give you some sort of a completion. If you do have several examples, okay, I do recommend to work in a few shot, and there I would start with Jurassic 1 Grande, right? Because it is right, it's a range where Jumbo is the most capable one, and then Grande, and then large. But Grande is much faster than Jumbo. Okay, and sometimes latency do have a lot of effect in production. Okay, in demos it's really less important, but in production it really matters. So I would start with Grande. If you see it doesn't work as well as you thought, go to Jumbo. If it works really well, you can try large. But also, don't work hard if you don't have to. If you just want, you have like a bigger system and you want to get something which is summarizing or correct me some grammar errors, just use a task-specific API. Okay, just integrate it in your system. It's really easy. It's really something that you can just learn again. Here you can see in our docs the overview of all the task-specific APIs that we have. For instance, if we will go through the paraphrase, okay, you see here there's a lot of explanations, a lot of examples, and there's also calls in our API reference where you can just go and see all the parameters to do it. So I do recommend work smart, not hard. How to engineer my prompt. So check several phrasing, okay, and see what works best. Evaluate on temperature 0 first or low temperature, okay? Because if something is giving you really weird results on low temperature, remember, low temperature is what is most probable for the model to work, to provide. Okay, so if it's giving you really weird stuff on low or 0 temperature, it won't work. However, expect repetitions in low temperature. Okay, so if you want something to be creative, work with low temperature just to see if a prompt is on the direction. If so, increase the temperature and then check it again. You can change the order. A few short examples. You can see here, for instance, okay, this is the same prompt, just shuffled the order, and you see that we get here Rick and Morty the musical, and here Rick and Morty's Back to the Future. Okay, the order does matter a little. Make sure your examples are varied. What do I mean? So you can see here the examples. This is a 3-shot, and all of the examples only contain Morty. So Morty, and then you can see that in the completion we're getting Morty's not Morty. Okay, so why that happens? All the examples show just Morty, so the model understands that this is the pattern it wants to work in, and then it will just give us a lot of Mortys. So make sure you're varied. Also, it's really important, use the same structure or template in all of them. Okay, if this is my prompt and in every example I have a different instruction, this is not a pattern. This is not something that the model will catch on easily, and it will just confuse it and will provide suboptimal results. And really, it's all about the data. Okay, so work with clean data, do pre-processing if possible, add post-processing. That's really important. And really, it's supposed to be fun. Okay, I'm having the best time of my life right now. I'm hoping that you will also enjoy this hackathon, and really bring your A game. Okay, because we're here, really excited to see what you'll do. The first hackathon was amazing. We were blown away. We were set, and we really enjoyed, and we're really expecting to enjoy again. If you have any questions, I'm very happy to take them right now. I will also say that both Yotam and myself will do an Ask Me Anything session next week. Okay, it will be on Monday, I think 3 o'clock CET. We will post about it on Discord, okay, on LinkedIn. You will see all the details. So you can either come chat with us if you want to talk about something in your project, whatever you want. It says ask me anything. We literally mean anything. And let's be friends on LinkedIn. Why not? So thank you very much.